I tried anyways to put some small talk in the presentation, so. But so also, I have like I'm late already, so I have like half an hour to teach Git. That will not happen.
You can
No, yeah, but it will not happen that people will learn in half an hour. So I will just show. I don't know. So I will. The thing is, I will start. So yeah. So this is actually a Git presentation. If you want to, there are two other presentations that are more small talk oriented. So one is the presentation on Iceberg that will be tomorrow afternoon, and another one on Friday morning. Actually, I don't know if all the slides will work because the low part of the slide is cut. So
yes, we should get
we will check. So, and then on Friday morning we have how to contribute to Pharo using the new process, using Git and blah blah blah. So there will be some more small talk there. But don't worry, I will try to put some things. No. So the first thing that I want to say is, okay, why Git? So people will say, yeah, I know, I'm good with Monticello, Envy, or whatever. I will not force anybody to use Git. So you use Git if you want. This is why we chose to use Git in Pharo, and why I put all my personal projects on Git since already 1 year. So first, visibility. Everybody in the world is using Git, so actually putting projects on Git just makes Pharo in particular much more visible. And people will not say, but what is Pharo? Does it exist? No, actually, so yeah, it exists now. We have many projects out there, so come on. It allows us to also manage not only code, we can have external files, we can have pictures, CSS files, JavaScript files. I know if you want to manage a project with just more than code, a web application, you can do it. Also, it has a lower entry barrier for the community. So, 19 years old, they will say, yeah, how can I know Git. I know Git, they will say. How can I use that in Pharo? Before 1 year ago, 2 years ago, we should have said, no, actually you can't. Or it is like that, yeah, you have to first export the source file. Yeah, so now it is much easier. Another point is that there are a lot of existing tools. So if you don't want to use Iceberg, you can still keep using file-free, and there are a plethora of tools out there that you can use. And analysis tools and whatever, so there's a lot of things. And there is good branch support, good deep support. That doesn't mean that other tools don't have it, but the good point about Git is that it is there. So I don't have to maintain the branch support and the Git support in Git, and we don't have, actually one of the things that we are thinking about is to not having to maintain a Smalltalk hub anymore. Actually, it's a lot of pain doing that. So being able to rely on GitHub, it takes us some pressure from us. So that is, wait. This could have been also why not Git, but I will let you choose your own reasons for using or not Git. Now, for those that may know Git, I will make a little survey. So, where do you place yourself? So, are you the baby? So that is a baby strong. It's a baby strong. Smurf. Sorry. So, are you the very Smurf? That knows not so much about Git, that is kind of a newbie? Are you the philosopher one that actually, yeah, I know Git, or are you the one that actually has some expertise on it and is the old guy, yeah, no, okay, you should do that, but not that. So, who is the baby here? Who's the baby here? Okay. So, who thinks that he's a philosopher? Okay. Who is the one that master? So there is one master, two master. Okay. So I have been working actively on Iceberg for 6 months already. So in a tool that actually manages Git and so on, and doing not only the binding but managing a lot of things around Git. And I put myself between the two ones, so the two first ones. So to me, one of the things that the more you know about Git, the more you know that you don't know it. So there are more things that I have to learn. So just that you don't feel bad. So for those that are experts, I forbid you to answer this question. So let's make a little test. So how do you clean your working copy? Yeah, I want you to, if somebody can tell me that. Already, if you don't know what a working copy is or what do I mean by the working copy, I think you're a baby. But
I have a script called unfuckup.
Unfuckup. Okay. So.
It does like checkout minus hard reset plus.
Yes. So it was that way. So what's the thing that? So how many of you have searched on Stack Overflow for something like this? Okay. Thanks. But really, you need to check in Stack Overflow for this kind of thing. Because you say, yeah, this is something so simple, but the first thing that people will say, yeah, you just need to use git reset. But no, that resets something else that is called an index, and I will try to not go inside on what the index is. This talk is not about that. I will go over it a bit, but I will not talk much about it. But this resets the index, so it doesn't reset your working copy, it will not touch any file of you. So actually, somebody in Stack Overflow may say also, yeah, no, you should use git reset hard, so you should reset it really hard. Yeah, give it hard. So it does kind of that, so actually what it will do is not to reset completely your working copy, it will reset your index, and it will reset your working copy to the state of your index, but it will not remove any untracked files. So that means that if you run a process that created new files and new directories in your working copy, they will stay there. And you will do a git status and you will say, why do we have that file there? Come on, how can I get rid of all those files there that I don't want to care about? So the fatality, because actually Git is made of fatalities, is to actually, after the git reset call, is to also do a cleanup. Also, be careful, because if you do this, actually you are removing files from your system and you cannot recover them. So, but that is why it is a fatality also. So, with this is that, the only message I want to pass around is that if you want to do something simple as cleaning your working copy, you have to do a lot of strange stuff, and there are a lot of options there that like you can reset with many. You can reset soft and reset hard and reset without anything, and that I think that's a soft. I don't know. And then you can send arguments to it to say I want to reset to that commit, but that has a strange effects if you don't know what you are doing. So, if you put that in a bash script like Elliot, it will work. So the thing is that, okay, Git is not easy. Actually, Git is easy, but it's not easy. So there's a lot of new terminology for those that are used to some other version control system. Yeah, you have the index, head, pull, push, fetch. Things that in other systems that doesn't exist. Maybe they have other names. And also, so maybe they have false friends. Because commit doesn't mean the same in SVN than in Git. So actually one has only effect on your machine, on your file system, on your repository that is here, and the other one will actually send stuff through the network. So they are not the same. Also merge, we will see merge afterwards. But merge in SVN, for example, is a text-based operation. So you are merging text. And in Git, it has also some effect on the commits and on your database, on your repository. So it is also command line oriented, so people that are not used to it, they will sometimes not feel comfortable about it. The documentation is sometimes ambiguous, sometimes incomplete, it says afterwards. So I don't know, when doing Iceberg, sometimes I wanted to say, what is the semantics of this thing in Git? And you go to the documentation, to the man page, and you say, wow, that is not documented. It doesn't say what happens if I launch this command without any argument, or with this argument but no the default thing there. So sometimes it is, so the only way to know the semantics of this thing is actually to execute it and see what it does. So the other thing that it makes it difficult is that actually it is so simple that you can do a lot of things with it. So there are a lot of workflows out there. People think, no, you should use rebates. There are a lot of conferences, I see the presentations where people will say, you should not use branches. You should not use this, or you should use that. So actually, there are many different ways to use it. You can actually use Git like SVN if you want. You can try to just pull and push directly without managing different repositories. So you can do really simple workflows, but there are other more complicated that you can have also. There's no perfect one. You have to adapt yourself. Your company has to adapt to what you want to do. Your project has to use what you want to do. But there's no one that is the best one. And also, people tend to mix the workflows with their own philosophy and the technical solutions, because people will tell you, no, that is bad. And no, it's not bad. Actually, the thing is that, yeah, everything that you do will have a trade-off. So you have to take decisions, of course. But as soon as you choose a workflow, stick with it, and okay, you have to understand what is wrong and what is good and bad with it. But there's no the best solution for it. So if you try to read some blogs around Git, so people will say, yeah, you should do that, and sometimes, okay, it doesn't adapt to your particular case. And also there are things that, there are a lot of graphical tools. I don't know, have somebody used the GitHub graphical tool, the desktop GitHub tool? Okay, so around a third. So if you use that tool particularly, you have seen that it is a really specific tool to read. A really specific tool. So actually it's really simple, it doesn't let you do anything. It sticks to a particular workflow and you cannot go around it. So you have that kind of tools, you have other kind of tools like source tree that lets you do anything. I know some other tools that actually let you do drag and drop of commits, and that makes merges and so on. So if you know what you're doing, you can use that kind of tools that are the overcomplicated ones. I don't know, it depends. So, but this only makes things difficult because you don't know when you arrive, you say, which tool should I use? Well, should I stick to that? What is the best one for me? So this makes things difficult. And the other thing is that when we start mixing Git with Smalltalk, it makes it harder because we have more for friends, we have more terminology to add to it, we have the problem that we have image-based persistence. So what happens with my repository if I save my image and then I touch my repository behind? So there are strange things that happen. So also we have the thing that Git stores files, and we have no files. We have packages, we have code, we have classes, we have methods. So we have to do the translation on that. There is the problem of managing files from Iceberg right now. So we will talk a bit about that tomorrow afternoon. So, but yeah, it's complicated. So I will present you in some slides a conceptual way to understand Git. This is how I explain somebody Git when, I don't know, I have a student that arrives and he doesn't know Git. Okay, so this is the basic that you should know. If you know this, then you can build on top. Yeah? So you can, I don't care about the fatalities. I don't care if you have to say hard or not. That you can check in Stack Overflow. But I really care that people understand the basics behind it. So there are 2 points on it that to me are really key to understand it. So first is a graph. That is why actually there is a graph in the logo of Git. I don't know if you ever noticed. So there is a graph because it's a graph. And the other thing is that there is a two-stage database. We will go around it with examples. So the first thing, when I say that Git is a graph, it doesn't show everything. So it's a graph, actually it's a database that we have a graph inside. In this graph, each node is a commit. So when you do a commit, actually you're creating a node in this graph. And the relation between the nodes in this graph is the parent relation. So a commit can have one or many parents. Or for the case of the first commit in a repository, it has no parents. But so a commit has parents. And then there's other things that are called references. So there are many kinds of references. There are particularly 3, two that everybody knows and one that maybe not everybody knows. So the first easy one are the branches. So a branch is a reference that can move. So for example, master, it's master branch. Yeah. So it's a branch that points to a commit. So it's a reference to a commit. And when I say that it can move, it means that today master will point to some commit and tomorrow it will point to some other commit. Okay. The other kind of references, like the one on the left, are tags. So everybody knows tags. So a tag is a reference to commit and short tags. The main difference between a tag and a branch is that tags are not meant to be moved. So once you put a tag, you should not move it. Git will allow you to do that because it's just a graph and references. But conceptually, you shouldn't. And then there is a third kind of reference that is called head. There are probably many other ones I don't want to go. But head is really important to understand. So head means where are you working on right now? So you are working on the master branch in here. And the master branch is on the commit B8, BF something. So that actually makes, we can make two conclusions of that. So the most important thing is that actually a repository, when we're working with Git, everything is contextual. So we are working on, you are working on something, so you are working on what is checked out in head. So every time, so you don't work and commit directly in any place in the graph. When you do some operation, you normally do that operation on head, or on what is referenced by head. So, and based on this, we can explain many of the Git operations. So, for example, if we want to commit, so let's think about this graph. So we have a really new repository. We have head that points to master, and master points to the first commit. So if I commit in this repository, actually what will happen is that a new commit will be created, and the master branch will point to the new commit. That's all. There are more things that will happen with files and so on, but on the graph part, this is all that happens. So actually the master pointer will just move forward to the new commit, and head will stay the same. Head will point to master, so head doesn't change. Actually, head changes implicitly, because master changed. So, but there's no movement actually. So that is a commit. So if somebody played with branches before, so what is a branch? So the branch operation in Git, it only does this. It creates a new reference that is called like that will have the name that we asked, and that branch will point to the commit that was pointed by head, to the endpoint of the. So it will actually resolve the reference that was pointed by head, and it will make that branch point to that. Just notice here that actually, if you use the branch operation in Git, it doesn't change head. So actually, it creates a new branch, but it doesn't change what was checked out in the system. So that's why people in Stack Overflow will tell you that probably the good way to create a branch is to do a checkout minus B, because actually checkout minus B does something else. So that not only creates a branch, but also changes head to tell you, now you are working on the development branch. So if in this case now we commit again, what will happen is this. We create a new commit, the master branch will move to the new commit, but the development branch will stay pointing to the commit it was before. So actually changing master doesn't change development. So far so easy. If I don't know how much. Let's go to another graph. So this is what a branch looks like when it grows up. So actually they diverge. The story diverges, and then that is why we need merge points also. So in this case, actually we have two commits that have diverged. So the development branch points to one commit, the master branch points to another commit, and we have head pointing to master. That means that we are working on master. So the checkout operation, when you do it from the command line, actually, if I want to check out development, what happens is this. I change the reference of head to development, and that's all. So this means, okay, now I'm working on development, and if I commit in this state, that means that my commit will go on the development branch, not on the master branch. The master branch will not be touched at all. Have you ever, if somebody played with checkout and checkout in branches and tags, have you ever found the detached head state? Who found the detached head state? Half of the people. So for those that don't know what the detached head means, it means that actually your head is pointing to a commit, and that's all. So it's not pointing to a branch, but to a commit. So that means that actually behind this graph there is a garbage collector. So if you commit on head and then you change to another branch, then if your commit is not being referenced by any reference, it will be garbage collector. So you have to be careful when you're in the detached head. You can work on the detached head in your Git, but you may lose your changes. So that's why actually Git will warn you about the detached head state. So actually, if you want to get out of this detached head state, the only thing that you need to do is to create a new branch, and that's all. You create a branch, you check out that branch, and that's all. That that gets you out of the detached head. Then it depends on on your particular scenario what you want to do. Then the other operation, yes.
Sorry, once again, there is a garbage collector? Okay.
There is a garbage collector that runs from time to time, you don't care. But it's completely transparent.
I didn't quite get it, but I don't know what that is.
There's a garbage, so a commit is being referenced by references. Either it is being referenced by a tag, by a branch, or by a parent commit. But sometimes you may create, for example in the attached head state, you may create commits that are not being referenced by anybody. It can happen. That is why I'm just warning about the detached head state. So if you do that, that means that afterwards, if that commit is not being referenced by anybody, it may get garbage collected, that's it. It's like an object that is there and nobody references to it. So that means that actually you don't have a pointer to it, so you can access it. You cannot access it. So that's
But it has an ID, I can go back to that.
it has an ID, yeah, but eventually if you don't have a hard reference to it, it's like actually having the ID is like like knowing the address in memory of the object. Yeah, you can go back to the address and point to the object, but eventually that address you don't know. So we can go and talk about the attached head. We probably will talk a bit more about it tomorrow for the iceberg part. But the message here is be careful with that. When you're in the attached head, you probably have to do something to fix the state of your repository. So the next operation is merge. So here we are in the same tree as before, same graph as before. So we have actually two branches, the development and the master branch. We are working on the master branch. So I want to merge what I did in the development branch into my master branch. So what does it do in my graph if I do that? So merging is not just a text operation, as I said before. Actually, it's an operation on the graph. So actually it creates a new commit that joins the history. So that will actually contain the contents of both branches. So the result of the textual merge will be contained in this commit. And this commit and merge commit, you can recognize it easily because it has many parents. Yeah? So the other thing that it happened that, I don't know if you noticed, I was in the master branch, so I merged from the development branch into the master branch. So the only branch that is modified is master. Development is not modified at all. So you can go back in history if you want, you can go back to development. Development is not touched. What else? So that is kind of. I will not explain about conflicts. We don't care about conflicts. So that will make the talk much more longer. Who have ever read about fast forward? Okay. So sometimes you do a merge, you do a pool, and you have something that is called a fast forward. So that is a kind of merge. So imagine we are in this scenario. So we have a master branch, we are working on the master branch, but we have a development branch that actually, we started it from the master branch, but then we made a new commit. So the master branch is what we have, they are in the same history. So it's like, the history didn't diverge. If you think about the time traveling metaphors, we are still coherent in the history. So we are not erasing anything. So development is what we call ahead of master. So it's master is behind development in the history because there is a single history. So when you read behind and ahead, it means that. So if in this case I try to merge development with master, actually there's no content to merge. So you don't need to do any merge textual merge because actually all the development changes were made on top of master changes. So actually what happens when we try to merge in this scenario is that, just move the pointer. And that is what is called a fast forward. A fast forward is just moving the pointer in master to point to the commit that we are merging because the histories are compatible. So the history didn't diverge. So it's just that there's nothing else to say about fast forward. So far, good. Somebody learned something here. No, that's good. No, because I actually was really skeptical about this, and you see, yeah, maybe it says things that are really true. So the other thing that so we can, all the operations that we shall saw, commit, pull, not pull, we didn't see pull and push yet, merge, checkout, and so on. We have actually two ways to see them. One is the graph view, the other is how about the files? What happens with my files? So, and there's where the two-stage database comes in. So actually, a Git repository has three parts, kind of. So I will read for you because it's kind of. So the first more important thing is the repository. The repository is where the commits are. So when I told you there is a graph of commits, that graph of commits is stored in a repository that is like your database that is in the it's hidden actually for you. So if you dissect the Git repository and check what's inside the .git directory, you have seen that there are some binary files, strange things there. So the repository is there. We have a database with the commits in there. Then there is another thing that is the index. The index, we will not care too much about it. We will say that it's a hidden staging area for changes. So when you're ready with your changes, before moving them to the database, you put them in an intermediate step. That is the index. So that is why I say there's a two-stage database. And you will understand better when I start explaining the operation side. And then there's the working copy. Sometimes people call it working directory also because the working copy and the working directory is one directory. So, but that is what you see actually. When you see your files, actually what you're seeing is the working copy. And when you change, actually when you do a Git status, what happens is that Git will compare the working copy with the index and the index with the repository, and he will tell you, you have so many changes between the working copy and the index, and so many changes between the index and the working directory, and the repository. So, and that is why there are two different divs there. So you have the tracked files and tracked files. So, when you want to commit, actually there's a previous operation that we have to do before committing, which is add. So when do we have to do add? So, add means to move things from the working copy to the index. So imagine that you are going to the supermarket and you want to buy something, I don't know, so like shampoo, because right now we are out of shampoo in the RMoD. So I want to buy shampoo. So before actually going to the cashier and pay my shampoo, actually I have to take it and put it in my cart. So if I don't put it into my cart, then I didn't take any shampoo. So you have to imagine this as, okay, you put in the index everything that you want to buy, before buying. So before doing the transaction, you actually go and choose everything that you want to add in that transaction, and you put that in the index. So that's it. So that is why we need that. And once we added everything that we needed into the index, we commit. So commit is just to move what we chose in the index into the repository. Actually, that will create a new commit with the contents of the things that we put in the index, and then it does the same thing that I explained before with the graph. So the checkout operation, before I said that checkout will change head. So it will make head point to some other branch, some other tag, some other commit. So actually, from this point of view, checkout is just taking things from the repository and putting them into the working copy. It will also change the index in the middle, but I didn't care to put it in the slide because it only makes it more complicated. So it takes the contents of the commit and it will just create the files that represent that are there in the commit. So like that, your commit and your files, they are in sync. So, and they can work together. Now, we didn't talk about pull, push, and all that kind of stuff that actually happens in Git also. That is because actually pulling and pushing is not an operation that works on our local repository. Actually, everything that I just explained happens in your machine. There was no network operation on it. So, actually, if we want to do network operations on it, we have to do the actual fetch and push. So, what is fetch? So, I didn't actually. I skipped it before. So there's this GitHub stuff there. So there is this idea of having remote repositories also in it. So a repository, a local repository in your machine, it can know some repository that is somewhere else in the network. I don't know. Just with a URL, it will know that repository, and then you can operate on it. So fetch. The fetch operation means actually to go to the remote repository and tell him, okay, what are the commits that are there but I don't have? And then give them to me. Yes. So it will just take the new commits and put them in my repository. It will not change anything in my index nor in my working directory. Fetching doesn't create any conflict, it doesn't create any merge or whatsoever. So it just takes the commits and brings them to my repository. That's all. What does push do? So actually push is the inverse operation of fetching. So it takes the delta of commits, so the new commits that were in my repository but were not in the remote repository, and he will push them there. So it will send them through the network to the repository. It will not only send commits, it will only send updated references. So if you change a branch, he will say, now my branch here points to this commit. But so take that, update your branch. And that may create conflicts. That is when you have a rejected push, for example. We need more than half an hour to go into all details. So pull and push, so actually fetch and push. I didn't explain pull. So what's pull? So it's a fetch and merge. So you fetch stuff into your repository, your repository, you take the new commits, and then you merge the new commits, the last new commit that you found in the remote repository, into your head. And actually what happens there is that in the happy case, you will have a fast forward. And then nothing happens. The worst case, you have a conflict. Okay, you have to manage. So, that is what I have to say about it. The other thing that, so the next thing I will going to talk is how, okay, because this is a bit of a mess. So I see Git as the assembly code to actually manage your source code. Yeah. So Git will provide you some operations. We can provide some other higher level operations on top of it that will simplify your life. That is why many tools and many people will have different philosophies, because you may have different mental models on how to work on this kind of, on just a graph. Because on a graph you can do anything. So tomorrow I'm going to talk about Iceberg again. So Git plus Pharo is Iceberg. And I'm going to talk now about 4 points. How do we cope a bit with the complexity, what is complexity in Iceberg? That is to say that everybody has his own workflow to work on Git and his own philosophy. So actually, every tool also will have a philosophy. Iceberg has its own philosophy, of course. It's like politics. Politics is everywhere, so we cannot take politics out of things. So Iceberg has its own politics. So I'm going to share part of it. So the 4 tips of the Iceberg. The first thing, so this is the new Iceberg UI that Esteban started creating 6 months ago or so. So now it's the part of the default release. There are many ideas behind the new UI and the new implementation, but it's not an implementation actually. We didn't re-implement it. We worked on it. We enhanced it and we make it more robust. So one of the first things that we thought when doing the new UI is to show the good path. So that is why you have that toolbar there. So they did, okay, we want to show what are the main operations that you can do on a repository. That doesn't mean that other operations are forbidden. No, those are the main ones that are one click of distance. If you want to have some other kind of operations, you have to rely on context menus, or you have to just do more clicks to do them. Also, the idea is to simplify the view of people around the repository. So that is why sometimes you will see less and more operations also, because we adapt the operations that we do depending on the state of your repository. The other good thing to me is that we warn about destruction. So we really decided that every destructive operation, so every time that you will do something that may destroy your code, that may destroy your files, we are going to show you a preview before. Because I cannot decide for you if you want to check out or not your code. So that it is up to you to decide. So if you want to check out, first, before the checkout, we make a diff and we tell you, I will erase all that. Are you sure? So like that, okay, there is an agreement, and you can choose if you do the checkout or not. The same thing happens for the merge. Actually, we do a merge preview. When you're going to merge, before doing the merge, because the merge will probably affect your code, we show you, okay, this merge will affect your code this way. So it is up to you to decide if you accept this merge or not, if you want to change your code. Yes?
Is your preview based on your own model or...
Yes. Yes.
So how do you guarantee the correspondence between what Git will actually do and what preview computes it will do? This is my anxiety speaking, it's not criticism.
I control Git. I tell Git what to do. So, Git doesn't decide what to do there, I decide. So, I tell you, I will do these changes. So, when there are changes on files, I will tell you, there are changes on files. I will apply them. There's not much more to do. But when there are changes on code, on packages, so it is us that actually manage the code. So Git doesn't know about Smalltalk code, it is ourselves. So, but we have completely the hand on top on it, and we tell him what to do. It's not Git that decides. Actually, I will talk about that tomorrow, but the merge implementation that we have, the new merge implementation, is implemented on Pharo. Because we need to merge Pharo code, and if you need, so we need the semantics of the Pharo code to merge it properly, so that means that we need to implement it in Pharo. So, preview. So the idea is to be explicit. We don't do anything without telling you before, and if we do it, it's because there is a bug, and we have to fix it. So that is the second point. The third point is to guide out of the darkness. So probably many of you, if you have used Iceberg, you have found that sometimes your repository goes red. It says, yeah, I know, I am detached, I am on that state. So we are going to probably try to make it more simpler, the workflow, but still there are some cases where your image will get desynchronized with the repository, especially if you touch the repository behind the scenes. So Iceberg need to know, well, what happened with the repository, because before it was in this commit and now it's in this other commit, I don't know what to do. So tell me. So we have this thing that is called the repair actions. Still, we will talk like 3 times about the repair actions. So the repair actions, they are about, okay, your repository is in this state, I don't know what to do, so please tell me what to do. So I will guide you through the process of fixing your repository, but I cannot guess for you. You have to tell me how to fix the repository. So on the top of the repair actions, you have the reason. So why am I showing you this? So read it. Read this screen. When you have this screen, read it. Because on the top you have the reason. We can enhance the text and the messages and so on. But the idea is to explain people, okay, you are in this state and why. Then you have options, and if you click on one of the options, actually below you will have the consequences of applying that option. So if I want to discard my local changes and check out an existing branch, what will happen? So for example, you will discard all changes in your image if you do that. So if you had dirty changes, you change the class, you will lose that change probably. So just know about that. So if you want to go out of that, maybe you want to do some other thing, like creating a branch. And the fourth point is that we worked a lot on enhancing the API, so we want to actually use a clear language. One of the things that I didn't put in the slides, but it is one of the first things I did in Iceberg is to put an inspect button everywhere. So I can inspect any object in Iceberg, and that is by default. Every object in Iceberg is inspectable. So you can do right-click inspect, and then you have an inspector and you can do whatever you want on it. Because otherwise debugging, it is really complicated. So that is why also we worked a lot on the API, we worked a lot on writing tests, I will talk more about it. So, but it's interesting going around the API of Iceberg. You can check out the comments to see where there are false friends or not, and so The main API is really well commented. It will tell you what happens if you do this. So, if you want more Git, again, tomorrow or Friday. That is everything I had to say. So, thank you. Do we have time for questions? Or? Yes. One or two. Somebody? CRIStAL. Yes.
So do you support blame on method level for the step to work?
Not blame, but we can check the complete history of a method. We didn't implement the blame, but it's doable. So.
And for example, dissect functionality to go through the history of changes and identify where the bug is and identify.
We didn't implement bisect again. It could be done. The things that usually when you do bisect, what Git will do when you do bisect is that it will check out a new version of the code every time. I am really against checking out code without telling the user. Because actually in a small token image it is really dangerous, because that means that you will actually break the instances that are live. So the things, how can we do a bisect with live objects? That I don't have the answer. But it can be doable, but it is more than just Git, because Git works on that text.